Very good evening, students. Welcome to the SBI online bridge course classes now. Uh, we are dealing with the logarithm concept. So in the last two lectures, we come across the definition of the logarithm and important four notes of the logarithm and as well as the four important properties of the logarithm, students. So let me solve the problems based on the definition as well as notes of the four notes which I have given there, as well as the properties of logarithm. So based on these three things, let us solve some problems. So yesterday we did some 6 problems. So let me continue the problems, students, here. So see the see the seventh problem which we are doing now. So see the things here. Log 6 to the base 6, right? What will be the answer, students? Log 6 to the base 6, its value will be 1. So why? Because so one of the important note I gave there in the yesterday's lecture, that is log a to the base a is 1. We have to remember this, right? Log a to the base a is 1, right? So in the same sense, move for the eighth question here. So log 1 by 93 to the base 1 by 93. So it is same as this one here. Log a to the base a. Its value will be what, students, here? Its value will be 1 again. So now let me go with the next one here. Ninth one. Log 1 to the base 99. So what is the answer here? Log 1 is a 0, right? So the four notes, important notes, you have to remember there. So log 1 to the base, any base, right, which is positive base as well as other than 1. So then log 1 will be 0, right? So, so because of this, so it will be out here 0 then, right? So I taught about all these things here. And next, log 99 to the base 1, right? Just now I told you that the base should not be 1. The base should be out here. Base should be positive and it should not be 1 for log p to the base a. So base should not be out here. Sorry, other than 1. Base should be positive and it should not be 1. But what they have provided here, the base is 1. So that's why it is not defined. Not defined. You won't get any value for this one here, right? So logarithm of the value to the base 1 is not defined. Okay. So let me move on to the next problem, students, here. 11th one, just take it down here. Logarithm of 125 to the base root 5. Logarithm of 625 to the base 5. So let me find out these two values of logarithm here. So logarithm of 125 to the base root 5. What will be the value? Let us do it. So firstly, I'll be considering it as x, students. So logarithm of 125 to the base root 5. Let me call it as x. I want to find the value of this one here. So now let me convert logarithm form to the exponential form. So you know that. So how to convert logarithm form to the exponential form? So this is the way of conversion. Exponential form to what here? Conversion of exponential form to logarithm form. Right? This is the definition. Right? The exponential itself is log to base to the b, log b to the base a. Now I have to move in reverse here. They have provided like this: log b to the base a. I have to convert in the exponential form. How do I convert? Just take a as a base and put the power as x here. So in the same sense, right, I am going in the reverse way now. So logarithm, I am converting into the exponential form as like this, right? So that is root 5 to the power x is equal to what now? Is equal to 125. So I have converted it logarithm form to the exponential form. Now, as we know that root a is written as a raised to 1 by 2. Yes or no? The square root of a is written as a raised to 1 by 2. In the same sense, root 5, I'll be expressing it as root 5, I'll be expressing it as 5 to the power 1 by 2. right? 5 to the power 1 by 2. Whole to the power what here? X. So it is 125 as it is. So now again we have the laws of indices property, students. A raised to m whole raised to n will be a raised to m into n, right? So now here base is what here? 5. Keeping the same base 5, keeping the same base a here, we have to multiply the powers. So let me multiply the powers here. 1 by 2 into x. 1 by 2 into x will be x by 2. Yes or no? Here x is nothing but what here? X by 1 we can write. Numerator into numerator, denominator into denominator. 1 into x is x, 1 to the 2. Right? So what happens? So it's a 5 to the power x by 2 is equal to. So looking to this base, what is the base in the LHS side? Base is 5, students. So looking to this base, I have to convert this 125 in the form of 5 to the power something there. So it is 5 cube, students. Yes or no? 5 cube. 5 5 is a 25, 25 5 is a 125. So looking to this base, 125 I convert in this form itself, right? With the same base. That is 5 cube. 5 cube will be what now? 125. The 125 is written in this way. Now in the equation, bases are same, means powers are also same. So what I write now? X by 2 is equal to 3, right? So let me write here outside. This is x by 2. So base is same, powers are also same in the equation here, right? So power is what here? X by 2 is equal to 3. Just cross multiply now. X is equal to how much? 3 2 is 6. Now let me implement what x we have taken here. X is what here actually? X is logarithm of 125 to the base root 5. So what is the value now? 6. Got it? So the logarithm of 125 to the base root 5 will be what here? 6. Got it? So now let us solve the next problem here, 12th one. So solution. So I have to find out the value of logarithm of 625 to the base 5. So whatever it may be, consider it as x now, right? So convert logarithm form to the exponential form, students. So what happens? Right? 5 to the power x is equal to 625. So now looking to the base 5 here, convert in the form of base 5 for the 625 here. So you can do in the rough work also, students. Actually it will become 5 is to 4 there. So you can do in the rough work also there. 5 1s are 5, 1 carry, 5 2s are 10, 2 carry again, 5 is 125 is. So 5 25 will be 125. Again 5 5 is again 5 1s are. So 4 times 5 here, right? So 5 into 5 into 5 into 5, that is 5 to the power 4 I will be expressing here. 625 I can express by looking to this the work here. 5 is to 4 I can express. Now in the equation it is equal to sign here. In the equation, the base is same. Of course the powers are also what here? Same here. That is x is equal to 4 we get. What actually x is? X is logarithm of 625 to the base 5. So its value is what now? 4 we got. Got it? So this is how we do the problems on the definition here, right? So let me solve the problems on the same definition of logarithm here with level 2 problems, right? Logarithm of 243 to the base 9. Right, let me do first this one and I'll be going with the next one. So let me do some little bit level 2 problem on the definition of logarithm here. So let us find out the value of logarithm of 243 to the base 9 here. Solution, whatever it may be, consider it as x. Logarithm of 243 to the base 9, let me consider it as x, students, right? So now apply the conversion, logarithm form to the exponential form. Conversion now. What happens? 9 to the power x is equal to 243, right? So now here base is 9. If we think in the base 9, you won't get the 243 there. So that's why. So further you simplify this 9, students. So further you simplify 9. 9 can be expressed as 3 square. Agree? Right? So 9 can be expressed as 3 square to the power what here? X. So now think in the base of 3 for this 243. Right? So you can go with the rough work also. If you are thinking about, if you think about in the 9, you won't get this 243, students. So that's why I have more elaborated here. 9 further I split it in the form of 3 square. So now what happens to this 3? Now think in the base of 3 for the 243 there, right? 3 6 3, how much are 3 8s are 24, 3 1s are 81s are, right? So next 3 9s are, sorry, 3 27s are, sorry, 3 27s are, right? 3 2s are 6, 2 carry, 21 remains, that is 7s are. So 3 9s are, right? 3 3s are, again 3 1s are. How many times, students? If you know directly, you can express it, or else you can do in the rough work. 1 3 times 3 times 3 times 3 times 3. Total 5 times you can do here. That is 3 to the power 5. Right? I'll be expressing in the form of 3 to the power 5. Right? So now what happens? So now again use the laws of indices. A raised to m whole raised to n. E is what here? A raised to m into n. So the power, keeping the same base, powers I should multiply here. Right? 2 into x, 2x is equal to 3 raised to 5. So now what do you get in the equation? If base is same, powers are also same here. That is, what is the power in the left hand side? That is 2x. What is the power in the RHS side? That is 5. So I want x value. So x value will be 5 divided by 2. So what is x actually? Actually, x is what here? Logarithm of 243 to the base 9. So its value is what now? 5 by 2. Got it? So this is the answer of logarithm. You may get the answer in the form of fraction or point decimal there, right? So log of value should be what here? Positive. Base also should be positive other than 1. You may get the log answer as negative or positive or in the form of decimal, no problem, right? Got it? Now let me do one more here. You can pause the video, you can take down the problem, students. So I'll be moving to the next problem now. So which was 13th, now 14th one. Logarithm of 256 to the base 32. Let me solve this. Logarithm of 256. I want to find the value of logarithm of 256 to the base 32. So now same process we have to do, students, here. Consider, first of all, we have to consider this as x. Let logarithm of 256 to the base 32 be x. Right? So now use the conversion, logarithm to exponential, it becomes 32 to the power x is equal to 256. Now you see the base here. The base is little bit larger quantity, so we can simplify this base, students. So in the form of 2 you can split. In the form of 2 to the power 5 you will be getting 32 there, right? 2 to the power 5, that is you are getting what here? 32. So always think about what here in the form of prime numbers. As we know that every composite number can be expressed as product of prime numbers. We have to think the base in the form of prime numbers there, right? So 2 is a prime number, of course. So in the prime number 2 you will be getting 32 there. 2 raised to 5 you will be getting what here? 32. So the 32 I'll be expressing it as 2 raised to 5, right? So to the power x. Now think this 256 with the base what here? 2, right? You can do in the rough work. I told you that if you know all the things, you can do directly, or else you can go through the rough work. 2 now divide with 2, the base is 2. I'm dividing with 2 now. 1s are, 2s are, and 1 carry here, 8s are, right? So again, divide by 2 there, 2 6s are, 2 4s are, that's 64s are. Next, again, divide by 2, the 32s are. Next, 16. Next, 8s are, right? So 16 here, 8, again, 4, next, again, 2, again, 1. You can do with this process. So how many times to the power 2 will be 256 here? 1, 2, 3, 4, 5, 6, 7, 8 times. So that is 2 to the power 8 will be what here? 256. Got it? Now, again we have to apply the laws of indices property. A raised to m whole raised to n will be a raised to m into n. So the base is what here? 2. Keeping the same base, I have to multiply the powers. A raised to m into n. 5 into x, 5x is equal to 2 raised to 8. So in the equation base is same, power is also same here. The power is what here now? 5x. And what is the power here on the right side? That is 8. So x will be what here? 8 by 5. 8 by 5. Right? What actually x is? X is what now? Logarithm of 256 to the base 32. Its value will be 8 by 5. Got it, students here? I hope you are taking down these things there. So let me go with the next problem now. Fifteenth one. Logarithm of 100 to the base 0.1. Find the value of logarithm of 100 to the base 0.1. So let me call it as x first. Logarithm of 100 to the base 0.1. Yes, base. I told you about the base of logarithm, students. Logarithm base should be positive. Of course, 0.1 is positive, and it should not be 1. Whether 0.1 is equal to 1? No. So the base of logarithm should not be 1, and it should be positive. Yes, of course, here it is, base is not 1, and of course it is positive there. So now let me find out the value of this log 100 to the base 0.1 here. So implement the conversion now. What happens? 0.1 to the power x is equal to 100, right? So now you see, students, 0.1. 0.1 can be written as 1 by 10. Agree? 0.1 can be written as 1 by 10, right? You drop the point first. You drop the point. You are getting what here? 0, 1. So after decimal point, how many digits are there here? Only 1. So that means divide by 10 there. So after, suppose if you have like this 0.12, just drop the point 012, divide by. So after the point you have 2 decimal places. So divide by 100 there. Got it? So you know all these things. So 0.1 to the power x. So 0.1 can be written as 1 by 10 to the power x. So this 100, let me keep as it is here. So can I express 1 by 10 as 10 to the power minus 1, students? Yes or no? 1 by 10, I'll be expressing it as 10 to the power minus 1. But it is whole to the power what here? X. Got it? 1 by 10 I have expressed in this way, and whole to the power is x here. So now, thinking to the base 10 now. Thinking to the base 10, how do I express this 100? So 100 is expressed as 10 square. Thinking to this base here, 10. Okay? So now, 10 to the power a raised to m whole raised to n, a raised to m into n, right? That laws of indices property, let us apply. Keeping the base as it is, let us multiply the powers. Minus 1 into x minus x, okay, is equal to 10 square. Now it is in the equation here, base is same. Of course, powers are also same here. So that is, what is the power of 10 in the LHS side? That is minus x, here 2. So I need only plus x value here. So multiplying minus 1 on both sides here, minus into minus into plus will be minus. Okay. So what is x actually here? So x is logarithm of 100 to the base 0.1. So its value will be what here? 2. So we got the value of log 100 to the base 0.1 is 2. Okay. Next one. You can take down the notes, students, right? I'll be solving the problems here to cover more problems on the definition as well as properties here. 16. Logarithm of 64 to the base 2 root 2. Find the value of logarithm of 64 to the base 2 root 2. So how do you do this? The same thing, same procedure, students. So logarithm, let us consider logarithm of 64 to the base 2 root 2 as x. Correct? So apply the conversion now. 2 root 2 to the power x is how much here? Is 64. Correct? Now let me simplify these things first. Right? So 2, let me keep as it is. Root 2, how do you express? Root 2, I am expressing it as 2 to the power 1 by 2. Right? Yes or no? Root 2, I am expressing it as 2 to the power 1 by 2. 2 to the power 1 by 2. Root 2 is expressed in this way. And whole to the power what? Whole to the power x it is equal to 64. Let me keep as it is here. So again, we have to use the laws of indices property now. Here it is a product of two things, 2 and 2 here. So 2 is nothing but what here? 2 raised to 1. Yes or no? If I write simply 2 means it is understood that it is 2 raised to 1. So in the product, bases are same means what we have to do? We have to add the powers. Here it is nothing but what here, students? 1. So bases are same, powers to be added now by the laws of indices property. So now what happens here? Base I should keep as it is. Now I should add the powers here. 1 plus half here. 1 plus 1 by 2. Right? So to the power, whole to the power what here? X. Whole to the power x is equal to 64. Let me keep as it is here. Let me solve this. 1 plus half, 1 and a half. 1 and a half means 3 by 2. Or else you can go through with the rough work here. You know how to solve the LCM there. 1 is written as 1 by 1, right? So take the LCM. What will be the LCM? 1 into 2, 2, right? 1 how much are 2? 2 is 2 how much are 2? 1 is. So 1 into 2 is 2 plus 1 into 1 is 1. So that is 3 by 2, right? 3 by 2. So 2 to the power, what do you get this one here? 3 by 2. So whole to the power what here? X is equal to how much here? 64, right? Is equal to 64. Let me keep as it is. Now again we have to use the laws of indices property, students here. A raised to m whole raised to n. It becomes a raised to m into m, right? So that is 2 is a base. I have to multiply the powers. See the powers here 3 by 2 and x. So multiply 3 by 2 into x. That is 3x divided by 2. Here x is nothing but what here? X by 1. Numerator into numerator, denominator into denominator. So what happens here? 3x divided by 2 is equal to, now this 64. This 64 I have to think in this base here, looking to the LHS side. So what is the base in the LHS side? 2. So thinking this base here, how do I express this 64? 2 to the power 6. 2 to the power 6 will be what here? 2 to the power 6. 2 cube is 8. 8 is 64. That is, so 2 to the power 6 will be what here? 64. Now in this equation, base is same. Of course, power is also same here. 3x by 2 is equal to how much? 6. Now cross multiply this first. So 3x will be what now? 3x will be 6 2s or 2 6 are 12 there. Now again I need x value. Just cross multiply again here. 12 by 3. So what do you get? X value, you are getting it as 4. 3 1s are 3 4s are, right? So what is x actually? X is nothing but what here? Logarithm of 64 to the base 2 root 2. So its value is what now? 4 you got here. Right? 4 you are getting. Right? I hope you understood this one here. Right? You can take down this one here. Now, next problem. Logarithm of x to the base 5 is equal to 125. Sorry, 125 is equal to 3. Right? Is equal to 3. Next problem, students. So previously you have seen the problems, right? They'll be asking log of the value, log of 64 to the base 2 root 2 as what? But here in this, they have already given the log value as 3. Log value as 3, they have already provided. So for what log value it is being 3 to the base 5? So we have to find out that. So now solution, directly we should take this one here, given thing, what they have provided, log x to the base 5, they have already given the value of log x as 3 there. I have to find the value of x now. I have to find the value of x. In all problems, we have to find the value of x there. So now, use this conversion. 5 cube is equal to what now? X. Simple one. It becomes what here? 125. Right? 125. Therefore, find the value of x, they will be saying here. Here, they will be asking, find the value of x. Right? So we'll be getting the x value as 125. Cube is 125 after conversion of logarithm to the exponential form. Right? Simple one, right? So now let me do similar problem one more here. Right? Find x if logarithm of x to the base 0.4 is equal to -3. Logarithm of x to the base 0.4 is equal to -3. So then what will be the value of x here, right? So let me take the given thing here. What they have provided? They have provided this logarithm of x to the base 0.4 value is -3. They have already given the log answer as -3. Then for what log value it will be -3 there. So apply the conversion, students, now. 0.4 to the power -3 is equal to x. Correct? Is equal to x. Now 0.4 to the power -3 can I express in this way? 1 divided by 0.4 to the power 3. Correct? So a raised to minus m is expressed as 1 by a raised to m. You know that, right? So in this way, 0.4 to the power -3, I am expressing in this way 1 divided by 0.4 to the power plus 3 is equal to x. So now you see further 1 divided by again in the denominator, students, in the denominator 0.4. How do I express 0.4? Just now I told you that in the previous problem, that is drop the point. If you drop the point, it becomes 0.4. 0.4 means 4 itself. So divide by, after the decimal point, how many digits are there? 1 digit. So divide by 10 there. Right? Divide by 10. So 0.4 can be expressed as 4 divided by 10. It's a whole cube they have given. Write a whole cube here. Right? 4 to the power 3. In the denominator, we are doing the things here. Is equal to what here? X. Right? So whether we can cancel in the denominator, that in this bracket here, yes. 2 2s are here, 2 5s are. Right? So what are the things remaining here? 1 divided by 2 by 5. 2 5s are 10, right? 2 5s are 10. Yes or no? So 2 2 by 5 to the power 3 remains is equal to x. So now what happens here? 1 divided by, what is 2 cube, students? 8. What is 5 cube? 125 is equal to x. Now further, whether it flips like this here, this 125 goes to the numerator, right? So 125 divided by 8 is equal to x now. So what is the value of x now? 125 divided by 8. You know that this 125 goes to the numerator. You know the basic idea. If you have like this, a by b whole divided by c by d, how do you express? So whatever may be the numerator, you keep as it is. Into you write on, flip the denominator, students. That is AD by BC. So if you have like this, if you have in this way, what you are doing there? What you are doing? A divided by B whole divided by C. So here denominator C is nothing but what here? C by 1. So whatever may be the numerator, write down as it is and write down multiplication sign and flip it. You will be getting 1 by C. That is A divided by BC you are getting. Or else in another case, if you have like this case, right, this one here, A divided by B by C, if they have provided, whatever may be the numerator, keep as it is, write down into and flip the denominator, C by D. You are getting what here? AC by B. You know this thing here. So I have explained the basic thing. So what happens? Whatever may be the numerator, keep as it is, flip the denominator. That is 125 by 8 will be the value of x. Okay. So these are what here the problems based on the definition and the 4 important notes. Now let me solve the problems based on the properties of logarithm there. So what are the properties of logarithm? Let me recall one, students, directly. So properties, what are the properties, students? First one, log m into n. What is log m into n, students? Log m plus log n to the base e. Multiplication converts as addition, right? So if you can, in the problems you have to apply in both the sense here, right? If they have given in this way, you have to express like this here, log m plus log n. Or else in the question they have provided in the form of log m plus log n, you can convert in the form of log m into n. In both the way you can apply while dealing with the situation of the problem there, right? So what is the second one here? Log m by n. Yesterday we discussed about these things there. Even proof also we have discussed. So log m by n is what now? Log m minus log n. You have to remember compulsory all these things here, right? Third one, log m to the power n, right? It will be, I told you if these are variable, no need to express e. It's a natural logarithm. So that is n log m. Log m raised to n will be n log m. And fourth one, what is the fourth one, students? Log m to the base n. Log m to the base n will be what here? Log m divided by log n. Log m divided by log n. Got it now? So these are the 4 properties you have to remember, students. So based on these 4 properties, let me solve the problems here. So we did 18 problems. Let me solve the next other problems there, right? Based on this logarithm properties. Now, 19th one here. Show that log L by m plus log m by L is equal to 0, right? So now we are dealing with the variable, students. I told you, right? Logarithm of the thing, if they have provided, the base is always what here? E. That is a natural logarithm. So if you are not mentioning it, no problem, right? If you have the numerical values 1, 2, 3, or 4, yeah, something here, right? Log of numerical value. Always the base will be what here? 10. And this, it is understood that it is a common logarithm. Here it is what here? Natural logarithm. So now we are dealing with the variables. It is understood that the base is what here? E. Okay. So these are the problems based on the natural logarithms here, right? Property based problems here. So now log L divided by M plus log M by L is equal to 0. I should show, right? Let me consider the LHS here, right? So what is LHS? Log L by M plus log M by L. LHS will be. So what is log M? Log L by M, students? Log A by B or log M by N? What property I should use now? This one I should use. Log M by N will be what here? Log M minus log N. So what happens now? What happens to this? It will be log L. Put the bracket. While splitting it, you should put the bracket, students. Log L, log M. Right? You have to put the bracket. Why? The single quantity is splitting into the two terms. So that's why we should put the bracket. Okay. So next, again, log M by L, the same property. Log M by N will be log M minus log N. Same property, let me apply here. Log M minus, what happens here? Log L. Got it? So now let me split the bracket. Let me split the bracket. Open the bracket now. So log L minus log M plus into plus plus, that is log M, plus into minus minus, that is log L. Now see what happens here. Plus log L and minus log L get cancels. Yes or no? Plus log L and minus log L get cancels. Whereas this one here, plus log M and minus log N get cancels. Plus log M and minus log M get cancels. Right? 2 minus 2, 0. Right? 3 minus 3, 0, in that way. Right? So what happens here totally? All the things vanishes here. 0 you are getting. The 0, that only we have to prove here. That is RHS. Got it? So based on the property, based on this property, we did this one here. Okay. Now let me go with the next problem now. If x is logarithm of 9 to the base 7, y is logarithm of 7 to the base 5, and z is logarithm of 5 to the base 3, then show that x, y, z is equal to 2. Then show that x, y, z is equal to 2. Solution. Right? So now let me consider LHS. What are the given things? What are the given things, students? They have provided x as logarithm of 9 to the base 7. Y they have provided it as logarithm of 7 to the base 5. And z they have provided it as logarithm of 5 to the base 3. So I have to prove x into y into z is equal to 2. So let me consider the LHS here. LHS is x into y into z. So what is x here? X they have given log 9 to the base 7 here into y. What is y? They have provided log 7 to the base 5 into z. Z they have provided log 5 to the base 3. Right? So now now you see, students. So which property I should use? Which logarithm property I should use? See this. See this one, students. What is log m to the base n? Log m to the base n is log m divided by log n, right? Base is different here. Here base is n, here m. So log m divided by log n. If you convert in this way, of course the base will be e there, right? No need to mention if they have given like that. So log m to the base n will be log m by log n there. So let me use that property here, LHS. So log 9 to the base 7, I'll be expressing it as log 9 by log 7, right? So now you see, students, logarithm of a numerical value. Now what will be the base? Base will be 10. It is understood. No need to express it. Okay. So we are dealing with the numerical values there. So into log m by log m to the base n will be over here log 7 divided by log 5 using the fourth property into the same sense, that is what here log 5 divided by log 3. See what happens here. See what happens here. Log 7 get cancels, log 5 get cancels. So you should not cancel 3 1s are 3 2s are here, right? It is not the correct method here. So what are the things left out? You write on first. What are the things left out here? LHS is equal to log 9 is left out and log 3 is left out, right? So what I should show here, I should prove x into y into z as 2 there, right? So you should not cancel log 3 1s are 3 3s, no, right? So it is not the correct way. So what is the correct way here? I have to use the properties of logarithm there, right? So now 9, this 9 I'll be expressing with the base as 3 there. 9 can be written as 3 square, students. Agree? 9 can be written as 3 square. Yes. So divide by, what is the denominator here? Again log 3 is there here. So now you see 9 is expressed in this way. Now in what type of property I should apply now? Whether it looks like log m raised to n? Yes or no? What is log m raised to n, students? Log m to the power n is written as n log m. Yes or no? The power comes beside the log. Power comes beside the log here, right? This property, that is the third property. Log m raised to n is n log m. So I'm going to apply this property here. So what happens now? What happens to this LHS? Log 3 to the power 2. This power 2 comes beside the log 3 there. So 2 log 3. I have applied this property there, right? So divide by what? Divide by log 3. Now both are same. You can cancel it. Both are same. You can cancel it. What you are getting the answer here? 2. So 2 is nothing but what here? It's a RHS side. We have to prove that only. Got it? Simple, right? So we have used this property as well as log m to the base n property, right? Let me move with the next problem now. Which one here? Next, 20th one. Show that two by 3 log 8 minus 1 by 2 log of 1 by 4 is equal to 3 log 2. I have to prove this. So let me prove this, students, here. Solution. LHS, let me consider here. What is LHS side? It's a 2 by 3 log 8 minus 1 by 2 log 1 by 4. Log 1 by 4. Correct? Now, just see here. It's a log 8. whether we can simplify further this 8 here. Yes. 2 cube. What is 2 cube, students? 8, right? And also you should check the thing what we have to prove there. Log 2. So all the logarithm with a log of 2 I should make in this way here, looking to the RHS there, right? So we have to think this values in the form of base 2, right? So 2 cube is what now? 8. So this, it is 2 by 3. Let me keep as it is. And 8. This 8 can be written as 2 cube. Yes or no? Yes. So 1 by 2 as it is. Now 1 by 4. 1 by 4 I express in this way. 4 to the power minus 1. Can I write like that? 4 to the power minus 1? Yes. 1 by a can be written as a raised to minus 1 then. Right? Now LHS 2 by 3. So implement the property, students. Log m raised to n. What is the log m raised to n? Just now we did there. Log m raised to n will be n log m. Power comes beside the log. So what happens here? This power comes beside the log. That is 3 log 2. 3 log 2. Here minus half as it is, minus 1 by 2 as it is. Now, again, it looks like what here? Again, it looks like log m raised to n. Yes or no? In this form itself, log m raised to n. Right? What happens? This minus 1 comes beside here. Sorry. Minus 1 beside comes the log here. Log 4. Got it? Log m raised to n will be n log m. This property. Right? So now what happens? Here 3 get cancels. What remains, students? What remains? 2 log 2. Correct? This much remains here. Minus into minus plus 1 by 2. Minus into minus plus 1 by 2 log 4. So further whether I can simplify this 4 here. Looking to the RHS, I need log 2, right? Log 2 there. So 4, further I'll be splitting it as 2 square. Yes or no? 4 can be written as 2 square. So let me elaborate further here. Let me simplify further. LHS will be 2 times log 2 plus 1 by 2. This 4 can be written as 2 square. 2 square. So again it looks like log m raised to n. Again it looks like log m raised to n. So implement n log m there. So this power comes beside the log here. So LHS will be 2 times log 2 plus half. Here this power comes beside the log now. Log m raised to n is n log n. So 2 get cancels here, right? So 2 times log 2 plus 1 time log 2. How many times log 2, students? 2 log 2 plus 1 log 2. Totally, how many log 2s? That is 3 log 2. 2 times log 2 plus 1 time log 2. That is 3 times log 2. This only we need at the RHS here. This is the RHS we have, right? See the RHS. See what we want the RHS? 3 log 2. So whether we got the 3 log 2 here? Yes. Got it? So this is the thing we have to know here, right? You can take down this. Let me move on to the next problem. Show that 2 log 16 by 9 plus log 54 divided by 224 plus log 21 divided by 16 is equal to 0, right? I should show this, right? Show that 2 log 16 divided by 9 plus log 54 divided by 224 plus log 21 divided by 16 as 0 I should prove here, right? So now you see, let me consider show that they have given means solution, prove that they have given means proof. We have to write here solution. Let me take the solution here. That is LHS. Take the LHS side. What is the LHS side, students? Here 2 log 16 by 9 plus log 54 divided by 224 plus log 1 divided by 16, right? So at last you are getting the answer as 0, right? At what is the log value you are getting 0, students, right? You come across the definition and the 4 important notes there. So log, what value will be 0? The logically, right, you can think the answer will be 0 at what log value? Log 1 is 0. Log 1 to the base, any base with the positive base, it will be 0, right? Means if you simplify this, you are going to get log 1. By logically we can think that, right? So now you see, now what I have to do, just here 2 log 16 by 9. So we have the property, students, log m raised to n is what here? N log m. Agree? Yes or no? So let me move in the reverse way now. N log m. If it is of n log m, how do I express? I express in this way. Log m raised to n. So this is in the same form here. This one is same as this one here. Right? So how do I go into the reverse way now? Log m raised to n. So what I have to do now? Log 16 by 9. This I should take to the power here. 2 log m raised to n, right? N log m is expressed as log m raised to n. In reverse way I have applied here, right? I told you according to the situation we have to apply in both the ways, right? Next, let me keep these things as it is, students. Let me keep these things as it is. Let me do not implement any of the things here, right? I'll be telling you why. So now, what is 16 square? 256. Yes or no? 16 square will be 256 and 9 square will be 81, right? So now plus logarithm of 54 divided by 224 plus log 21 divided by 16, right? 21 divided by 16. Now we have the property. What is the property, students? Log m into n. It is what here? Log m plus log n. Agree? First property. Log m into n is log m plus log n. Now let me implement in reverse way now. If it is of log m plus log n, how do I express? Log m into n, man. Right? Here we have sum of 3 terms. Log m, log n plus log p. So how do I express? Log m into n into p. Got it? This property can be applicable for more than 2 things there, right? So now log m plus log n plus log p in the RHS form here, I have to convert in the LHS form, that is log m into n there. So what will be the thing here? What will be the thing here? LHS will be, so I should multiply all the 3 things. Log 256 by 81 into sum becomes multiplication there, that is 54 divided by 224 into 21 divided by 16. So log of single quantity, this log of product of 3 terms, log m into n into p, into becomes sum here, the log m plus log n plus log p there. Okay, so now now let me cancel the things here, right? What happens, you see here, 16 ones are 16, 16 16s are 16 square is 256, right? Agree? 16 ones are 16, 16s are 256, right? Next, further let me cancel with the help of 2 here, right? You can go with the 2 there. 2 2s are 4, right? 1 carry 2 7s are 14, right? Like this, right? Next, 2 I have 2 27s are 54 here. 2 112s are 224. So further again, in the form of 7, let me go with the 7 there. 7, okay, not 7 here. further cancellation, students. Further cancellation. What happens here? Further cancellation. What happens? Let me go with the 3 here. Let me go with the 3 students. 3 2s are 6. 3 2s are 6. 2 carry 21 means 2 3 7s are 21. I'm dividing with 3 now. I'm dividing with 3. 3 27s are 81. Here 3 7s are 21. Right? Got it? So now further you see, students. Further, what can I do here? Here 27 get cancels. Yes or no? The same thing. 27 get cancels. Now you see, students, 16 and 7 remains here. Here 12 remains. What is 16 sevens are, students? What is 16 sevens are? 112. Yes or no? Right? 16 sevens are, right? 112 you are getting there. So what totally what happens here? What you are getting? Log 1 you are getting. At last 1 you are getting there. Right? At last what you are getting there? 1 you are getting. So what is log 1, students? 0. If you cancel all the things get cancels, only 1 remains here. Only 1 remains, that is log 1 will be 0. Right? 16 and 7 are remaining there. 16 sevens are 112 and this 112 get cancels. Only 1 remains there. So log 1 will be 0. Got it? So now let me move on to the next one of the last problem for this definition as well as property of logarithm here. It's similar to this problem. Prove that 2 log 16 by 15 plus log 25 divided by 24 minus log 32 divided by 27 is equal to 0. You should get 0. You should get that. Right? Again, it is same as the previous problem. It is same as the previous problem. They are just we need 0. Here also we got the 0 there. So now it is same as the previous problem. Now you see they have given plus here. Here it is minus. Right? So now let me consider LHS. Right? That is, what is the LHS here? 2 log 16 by 15 plus log 25 by 24 minus log 32 divided by 27. So now how it looks like, which property I should use? See this quantity, students, it looks like n log m. So n log m. So I should think in the reverse way now, log m raised to n. So apply that one here. So LHS will be log 16 by 15 to the power 2. So next, plus let me keep these things as it is. So minus log 32 by 27, let me keep as it is here. Right? Now, what is 16 square, students? 16 square, 256. And what is 15 square? 15 square is 225. Right? Plus log 25 by 24 minus log 32 divided by 27. Let me keep these things as it is. Now we have the property log m plus log n. What is log m plus log n? Log m into n. First property, log m into n is log m plus log n. Now I'm going to apply in reverse with it. Log m plus log n will be written as log m into n. Right? So LHS log m into n, that is log 256 divided by 225 into this one 25 divided by 24 divided by 24. Log m into n is log m plus log n. I have applied in the reverse way. So this let me keep as it is here. Log 32 divided by 27. Now just cancel the thing, students. 25 ones are, right? 25 ones are 25, 25 nines are, right? 25 tens are 250, right? So if you subtract this 25, you will be getting 25. Then 25 ones are 25 nines are, right? Or else you can cancel with the help of 5 there. 5 fives are 5, 45s are, right? So then again 5 ones are 5 nines you will be getting there, right? So what happens here? 25 ones are 25 nines you are getting cancelled. Next, further what happens? 8. Further in the 8 table you cancel it. 8 how much are 24? 8 threes are 24. Next, 8 how much are near to 25 there? That 8 threes are 24, 1 carry 8 twos, that is 32s, right? 8 32s are 256, 8 threes are 24. Here 25 ones are, here 25 nines are. What are the things remaining here? 32 into 1, 32, 9 threes are 27. So let me write the remaining things. Sorry. Okay. Now you see. What are the remaining things, students? Logarithm of 32 into 1, 32 remains. 9 threes are 27. Further, what is the element? What is the thing left out here? Log 32 divided by 27. Both are same. Both are same. So 2 minus 2, what happens? 0. So in that same sense, log 32 divided by 27 minus log 32 divided by 27 will be 0. This only we have to prove that. So this is the RHS. Okay. Right. So these are the problems based on the logarithm or logarithm definition and 4 important notes, as well as properties of logarithm, students. So in the next class, I'll be coming with the further concepts of logarithm there, characteristics and mantissa, and how to find characteristics and mantissa of a logarithm, right? So I'll be discussing in the next class there. So until then, take care, students. Have a nice evening then. Exact 1 hour.